The first question wants us to calculate the length of AB. So that's pretty easy. We just use the distance formula. So we know that the distance formula goes like this. And so I'm just going to take A and B, and I'm just going to fill that into the formula. So for example, it would give us 3 minus 2. You see, so I used this as my point number 2, and I used this as my point number 1, but you can do it the other way around. And then minus 4 minus 3. Go ahead, type that in, and that gives you square root 26, but if we round that to 2 decimal places, then that will be 5 point, now that actually rounds to 10. Number B, if P is the midpoint of AD, okay, so if it was the midpoint, it would be somewhere over there, and they've said that that's P, show that the coordinates of P are that and that. Okay, so we use the midpoint formula, so we're going to take midpoint of AD. Now the midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. And so I'm going to use this as my point 1, and this as my point 2. And so that would give minus 2 plus 2 over 2, and then minus 3 plus 1 over 2. And so if you had to go work out this part, you get 0. And if you had to work out this part, you get minus 1. And so we do get the coordinates of 0 and minus 1 for P. Question C. Prove that BP is perpendicular to AD. So BP is this line over there. And they want us to prove that that is perpendicular to AD. So to prove that two lines are perpendicular, you need to calculate the gradient of each line, then multiply those two answers, and we should get minus 1. So what we're going to go do is we're going to work out the gradient of AD. Now we're going to use the gradient formula, which is y2 minus y1 over x2 minus x1, and I'm going to use this as my point 1 and this is my point 2, but you can decide what's best for you. And so that's going to be 1 minus 3 over 2 minus 2, and that gives us 1. Then I'll go work out the gradient of the other line, which is BP, and I will use this as my point 1 and this as my point 2. And remember that the coordinates of P are 0 and minus 1. And so that's going to give us minus 1 minus 4 over 0 minus 3. And that gives us minus 1. What we then do is we go multiply the gradients of those two together. And so that's going to be 1 multiplied by minus 1, which is minus 1. See that? That is a mathematical thing, that if you multiply the two gradients and you get minus 1, then the lines are perpendicular. So we can say, therefore, BP is perpendicular to AD. Question D. If AD is parallel to BC, so they're saying if this line is parallel to this line, then show that R is minus 3. When two lines are parallel, it means that their gradients are the same. So we can say that the gradient of AD is the same as the gradient of BC, and that's just because AD is parallel to BC. And so we can say that the gradient of BC must be equal to 1. Why 1? Because remember, when we calculated the gradient of AD earlier, we calculated it as 1. And so we can now say 1 equals to, now we can use the gradient formula between B and C. I'll use this as 0.2 and this as 0.1. And so that is going to give us R minus 4 over 4 minus 3. And let's just simplify that a bit. That'll become R plus 4. 4 minus 3 is 1. And so we're going to end up with R plus 4 equals to 1. And so R is minus 3. Question E. Describe how point B must move in order to make ADCB a parallelogram. So at the moment, it's definitely not a parallelogram. But if we could move B a little bit further down, maybe like over there, for example, then we might be able to get some type of parallelogram shape. It might even look like a rectangle, but that's okay, because a rectangle is also a parallelogram. So if you really want to be precise about where it is, we know that this line over here would be parallel to this parallel line, so let's do that. And then this line over here would be parallel to this one, so it would do something like that. And where those two intersect, it would be somewhere there. So it's going to be somewhere over there. Now, there is a very easy way to do this. What we do is, okay, and let's just pretend this is going to be the new B. So let's scratch out this, although we do need to know its original coordinates because we need to describe how it's going to move. But just forget about that point B for now. So what you do is you look at the following. Have a look at point D and have a look at point C and try see what happens when you move from D to C. So when you move from D to C, let's see what happens to the X values and let's see what happens to the Y values. So if you look at the X values, they're going from 2 to 4. So the X values, you're plussing 2. And if you look at the Y values, you're going from 1 to R, which was minus 3. So to go from 1 to minus 3, you're going down by 4. So we're going to go down by 4. So we can now take those little parameters and we can start at A and we can do the same thing. So we can go 2 to the right and then we can go 4 down, and that is where B would be, and we could easily get B's coordinates. So we take this minus 2 and we add 2, and so minus 2 plus 2 is 0. And then we take this minus 3 and we subtract 4 because we need to move that point 3 down, and that's going to give us negative 7. And so point B would have to move to the points 0 and minus 7. So they said describe how it must move. So we'll say it must move, or in fact, sorry, let's go plot the new point B, which we said was over here, and the coordinates have to be 0 and negative 7. So what they now want us to do is they want us to describe how must this original B, how must that one move to get to 0 and minus 7. So if you see this is a 3 and this is a 0, so it means it must go 3 places left. So we can say 3 places to the left. And then we can see that it goes from minus 4 to minus 7. So we can say that it must also move 3 places down. So 3 to the left and 3 down.